So I've done all this and I save it into my files. Okay, do take note that you can actually also generate the code from there that you can reuse. So once you have done that, okay, let me bring up my filter that I have designed before. I have it in my map files here, right? Okay, so I bring it up, okay, so that I can use it in the filter analyzer app. Again, to invoke the filter analyzer app, okay, you can use the functions or go back to the filter. Okay, I will see. Okay, filter analyzer app. So it is here. Okay. Yeah. So I just I don't have a session here. I just import the filter, right? Okay. Because the variables already in the workspace, I just need to import the filter coefficients. For example, for the IR filter require numerator and denominator. And then I give my IR, for example, okay, not normalized. So this is the frequency. I can actually just import, for example, I have one, right? I don't close the app, so I can actually import the second one. So I will import the second one. Okay, the second one is the FR filter. FR filter, the denominator is one, right? We don't have that value. And then I just put that okay. So import and close. Yeah. So you notice the difference of this, and you can highlight when you highlight any of them, you'll be able to see the implementations output here, how many multipliers and so on and so forth. And look at the response. You can overlay this two, or you can actually create a new display and just show the display of this when you import the signal. Yeah, because just now I use the same display to import. So this is the benefits of having the signal analyzer, filter analyzer apps, right? So once you analyze your filter, you can use it. I know that some of you ask the questions like, how do I apply the filter on the corrupted channels and so on and so forth. Okay, yeah, for multi-channels, practically you can actually filter for each individual channel. All right, okay. Yeah, when you say channels, I believe it's not one set of signals, one channel. Okay. So you just after you design the filter, you need to make sure that you understand what are the problems with each of the channel. Okay. So we are done with the designing of the filter. Then you know that you can actually use the filter. So to use it, there's a filter functions, or there's a filter blocks in Simulink. Once we have done the filtering, the signal is good, good to go, means that it's ready for feature extractions. So how do we actually extract the features? So in MATLAB, we have functions such as, for example, you are going to extract the features based on the statistical information from the signals. So we do have statistics functions there, or there are some additional functions that's new where it is dedicated for signals. So like, for example, signal frequency feature extractor, or signal time feature extractor, and so on and so forth. So you notice that these functions are available since 21B, 21A, or even 24A, right? Okay. So this is a additional functions to help us to extract the features. Okay, we call it feature engineering from our signal. Right. If you are working with pulse signals like duty cycle, then we do have those functions to extract the features. For those who are working with frequency, we have functions to extract the features from the frequency informations. All these are located in the MATLAB documentations. Okay. So if you notice that, okay, I already covered, okay, all the 5 steps that I prepared for you today. To wrap up everything, I'm going to show you one of this example. So this is the whale sound that you can find in the shipping demo, where, okay, if you notice, yeah. So you notice that actually the whale is maybe singing. I don't know what songs that, okay, the whale is actually producing, but, okay, you notice that with the signal analyzer apps, okay, you will be able to extract the signal. So you can actually extract these signals and then put it as one of the signal. Okay, this is my ROA1, okay, and then this is the second one, and this is the third one. Yeah. When I look at the spectrum, I noticed that, okay, this whale sound has a characteristics of frequency around 170 hertz, and there's a harmonic of it. So if you are working with machine learning, for example, you want to identify, you want to recognize, okay, do classifications and so on and so forth, you can use this frequency domain information to extract the features for the next step, which is the next, okay, or, okay, another webinar, right? Okay. So here, okay, my role is to highlight to you what, okay, we can do with some of the apps, and I believe, okay, this is easy for those who would like to explore the signal, right? Yeah. So from there, okay, you can export it, and using those functions that I mentioned earlier on, you can extract the features, and from these 3 signals, practically you can extract using a function. Remember, there's this signal frequency feature extractor that's available recently. You can get the signal, okay, you can put it in a table, and you can use this one to train your machine learning. Okay, so that's, okay, what you can do. All right. So what I'll do, okay, I'm going to just show you, okay, before, okay, I end the sections. Okay, let me close this first. So this is the whale sound. Okay, let me bring up the signal. So I bring up the signal analyzer apps, and you notice that, okay, over here, and because I bring up all, okay, so this is the whale signals. Let me put as a one grid. So how do I actually look through this? Okay, is that I can actually set the cursor if you want to. So I say, okay, I want to get the 2 cursor, for example. Okay, and I can turn on the panel. And I say preserve the times. Okay, I can extract the times. I can extract between the time limits or between the cursor. So you notice that, okay,